Hey guys, it's Miss Keenum, and today we're going to talk about how to add and subtract mixed fractions. This is part 3 of our 4-part video series on fractions. If you missed the first 2 parts, part 1 covered understanding adding and subtracting fractions as joining and separating numbers. Part 2 covered how to decompose a fraction. If you need help with either one of those topics, go back and look at the previous recorded video. So to get started, let's talk about what a mixed fraction is. Before we can add and subtract fractions, we first have to know what mixed fractions are. So a mixed fraction is a fraction that includes a whole number plus the fraction. So right here, 5, this is our whole number, and then the 1/3 is our fraction. So a mixed number includes both the whole number and the fraction itself. Even though we're talking about how to add and subtract mixed numbers or mixed fractions today, I wanted to start off with a basic addition problem where the fraction does not include a whole number, it's not a mixed fraction, but it's just a basic fraction problem so that we can go back and rethink about just how we add fractions. Okay, so I have the problem that says 3/6 plus 1/6 equals what? Okay, so if I have 3/6, fraction looks like this. So that's 3/6 plus our 1/6. Okay, so right now we have the fraction 3/6 plus 1/6 shown. So see here I have 1/6 of a fraction. Each blue tile represents 1/6 of my fraction. Remember, my fraction is the pieces of the whole. So fractions make up a whole. My whole here is made up of a total of 6 pieces. So when I add the fraction 3/6 plus 1/6, I add my blue tiles together. So it looks like this. Okay, so I have 1/6, 2/6, 3/6, and 4/6. Because I have 4 tiles and each of those represent a sixth, my problem becomes 3/6 plus 1/6 equals 4/6. So what I do is I count each of these blue tiles that I added together, and I add the blue tiles from each part, from each fraction, together in the end. I count my blue tiles, and I have a total of 4/6. Notice that my denominator, my bottom number, did not change. It stayed the same. And I get this number by counting the parts that make the whole. So if I kept on going here, that would be 5 and 6. Okay, so I want to show you here how we would add the fractions if we were not looking at a fraction model. Okay, so if I have 3/6 plus 1/6, the first thing I have to look at when adding these is my denominator. Is my denominator the same in both fractions that I'm adding? If it's not the same, stop. We cannot add fractions with different denominators. But in this problem, my denominator is the same in both fractions. That number is 6. Because I had the same denominator, I can add these fractions. So what I'm going to go ahead and do is on the right side of the equal sign, I'm going to go ahead and put my fraction bar in my 6. My 6 doesn't change. I don't add, subtract my denominator. It always stays the same. So I have a 6 here. Now I can add my top numbers just like I would normally. So I add 3 plus 1 just like I would if they were whole numbers, and that gives me 4. So my fraction here, the answer becomes 4/6. So I keep my bottom numbers, the denominator, the same. Each of these numbers should be the same, which they are, 6. And then I add my top numbers, my numerators, together as I would in a whole number to give me the answer. Okay, so this one is going to be the mixed fractions that we were talking about. So here I have 1 and 3/6 plus 1 and 1/6. Fractions 1 and 3/6 plus 1 and 1/6. There's two different ways that I can do this. I can say, okay, I have my whole numbers and I add those just like I originally would, just like you're adding whole numbers. So I have a 1 plus a 1. That gives me 2. I have two whole numbers. Then I can go to add my fractions. This is the same problem I just have. So right here, each blue, dark blue rectangle represents a 6. So I have 1/6 plus 1/6 plus 1/6 plus another 6th over here. If I add those 6 together, I end up having 4/6. See how my bottom number didn't change? My blue rectangles, my dark blue rectangles didn't change size. They're the same size. So my 6 never changed. I just had to add up the number of rectangles. So if we wanted to show this with our pictures, it would become, now I would have 1, 2, then 1, 2, 3, 4, 6. So my answer would become 2 and 4/6. So once again, I just want to show you how to add these without the fraction model or the area model. So if I have 1 and 3/6 plus 1 and 1/6, what I do here is my very first thing is I have to make sure that my denominators are the same. My denominators are the same, which means I can move forward with this problem. So then I'm going to add my whole numbers. So my whole numbers here are 1 plus 1. So that gives me 2. Now, like I said, we double check that our denominators, the bottom numbers, the denominators are the same. They are, so I can go ahead, put my fraction bar, and then my denominator of 6. And then, just like we would add whole numbers, I add my numerators. So 3 plus 1 equals 4, and my answer becomes 2 and 4/6. So here we have a subtraction problem. This one is 3 and 3/5 minus 1 and 2/5. So just like we did when we added mixed numbers, we're going to subtract mixed numbers. So I first look at my whole numbers, 3 minus 1. So I have 3 boxes here, 3 whole numbers, 1, 2, and 3, and I take one of those away. So when I take one of those away, I'm left with 2 whole numbers. 3 minus 1 equals 2. Okay, now I have 3/5 minus 2/5. So right here's a 5th, a 5th, and 1/5. Each of the purple rectangles represents a 5th. So I'm subtracting 2/5 from my original fraction. So when I take away 2/5, I'm left with 1/5. And my answer becomes 2 and 1/5. Okay, so just like we were doing previously, I want to show you how to solve this one if you did not have the pictures to go by. So I have 3 and 3/5 minus 1 and 2/5. Like I said, the first thing we always do is make sure our denominator is the same number. So in both fractions, my denominator is 5. So I know that I can subtract this fraction without any problem. Okay, so we're first going to subtract our whole numbers, just like we did previously. So 3 minus 1 equals 2. Okay, then I double check that my denominators are the same. They are. They're each 5. So I go ahead, draw my fraction bar, and write the denominator of 5. Then I subtract my numerators just as I would my whole numbers. So 3 minus 2 is 1. So my answer becomes 2 1/5.